My fascination with calligraphy started in my home country, Iran, where for roughly 7 years, I formally practiced Nastaliq calligraphy, which is the predominant calligraphic style in Iran. Later, as I ventured into the creative industry as a graphic designer, I always grappled with challenges in digitizing calligraphy and the limitations of expressing it digitally. And this struggle was really what sparked my academic pursuit. I joined OCAD University in 2019 for my master's degree in the Digital Futures program. In 2019, when I started my master's studies in the field of generative AI, was undergoing a significant transformation. This was particularly evident in the advancement of generative adversarial networks, or GANs, which have been evolving rapidly since their advent in 2014. The launch of networks like Starlink 2 marked a milestone showcasing the ability to generate highly realistic and detailed imagery. This period was a turning point as it brought to light the unprecedented capabilities of generative AI in visual domains. By that time, artists were already starting to experiment with GANs in their creative practices, each, of course, adopting their unique approach to this new tool. I also felt a spark of inspiration as I saw new possibilities and affordances in this new technology. But my ambition was to apply it to something close to my heart, Nastaliq calligraphy. In the realm of GANs, one of the first challenges is creating a dataset that represents a visual domain. This is critical for enabling the AI system to be effectively trained so that it can extract and generalize visual patterns within a coherent domain. In preparation of the dataset, there should be some sort of regularization in place to ensure coherence and consistency. But still, there needs to be a range of visual features across the samples to provide meaningful diversity. When it comes to a script as a visual domain, the block structure of certain scripts, such as Latent script, is generally more aligned with the network architecture of GANs, which mostly requires square data samples. It also provides a more straightforward plan about the source of visual diversity. However, the inherently cursive structure of Perso-Arabic, coupled with its calligraphic intricacies, makes Nastaliq dataset creation more challenging. A typical method to create the relatively large required datasets is collecting available digitized material. But when we examine archival materials of Nastaliq calligraphy, we are immediately struck by the immense diversity in the samples. It displays a rich tapestry of compositional forms, varying background colors, unique visual artifacts, overlapping of forms, and baselines set at different angles. Furthermore, we encounter a range of frame sizes and highly illuminated and decorated pieces. This diversity, while artistically enriching, presents a significant challenge in developing an effective regularization strategy. The goal is to distill this complexity into a coherent and simplified form that captures the essence of Nastaliq calligraphy and is also suitable and digestible for a generative AI system. In addressing these challenges, I landed on the decision to distill the domain to its core visual elements. This meant stripping away the illumination and compositional complexities, focusing instead on the most fundamental building blocks in each data sample. The aim was to present the domain as a coherent whole while showcasing the broadest possible spectrum of visual features. This approach was inspired by the traditional practice of calligraphy. These fundamental elements are known as mufradat in Perso-Arabic calligraphy, which focuses on individual letter combinations and how different letters connect in unique ways. However, working with archival material poses several technical challenges to extract clean, and regularized data, which couldn't be tackled within the scope of a short master's project. So I opted for an alternative solution, which is a synthetic approach. For this, I used Mirza typeface by the amazing Iranian type designer Anilati Mostaghi, whose work was actually mentioned earlier this morning. Using the available elongations and alternative letter forms in the typeface, I created all possible permutations of fully connected letter combinations with up to 4 letters in each data sample. An example of a 3-letter combination can be seen here on the left, with 3 different forms for the second letter and a possible elongation between the second and the third letters, resulting in 6 permutations overall. This process could only partially be automated, and I had to make certain calligraphic decisions manually regarding what alternative forms to use and where to best put elongations. Also to oversee if there are any issues in the rendering of the samples. After adding possible valuations, I ended up with around 60,000 unique data samples of fully connected combinations. Later on, I augmented this data set to address the distribution imbalance caused by the exponential growth of 4-letter samples compared to the rest of the data set. This augmentation resulted in a final dataset of 125,000 samples. Using this dataset, and after more than 400 hours of network training and fine-tuning, a trained GAN was achieved with the ability to generate new samples in Nastaliq with recognizable calligraphic details, as you can see in the generated samples here. An important feature of this trained GAN is its ability to generate samples with a higher number of letters. Here, you can see samples with 5 or even 6 connected letters. Considering the fact that the dataset only presents up to 4-letter combinations in each sample, it demonstrates the capability of the AI system to extract and generalize high-level calligraphic features, which enables it to generate new combinations. Another salient feature of the trained GAN is that from a discrete and limited range of features in the dataset, it can form a continuous representation of the visual features associated with the domain. Here you can see interpolations in what is known as the latent space of the GAN that unleashes the dynamic nature of the forms and opens up continuous access to some of the calligraphic features. Accessing these continuum was the basis of creating a series of artworks. These works draw inspiration from the compositional style in Nastaliq called siyaq-mashq, which is characterized by its repetitive and overlapping forms. By venturing into generative AI's new affordances, I used up hyperdimensional latent space navigations as a new mode of creative expression to incorporate dynamic forms while staying afloat on the calligraphic management. Among the created artworks is this piece, which was shown during Tasvim conference in Doha in 2022, and a piece projected on the city landmark in Toronto as part of the citywide exhibition of RTO back in 2021. While this experiment, with its limited scope, opens up new creative possibilities, it also functions as a proof of concept for a larger blueprint of a full-scale AI-based generative system for calligraphic Perso-Arabic. Among the possible future developments, I can mention the use of archival material to present a wider range of calligraphic features instead of a synthetic dataset, the incorporation of a more structured data representation space instead of a pixel space, and most importantly, adding conditional generation capabilities. While the technical complexities inherent in such developments should not be understated, it should be noted that these complexities are comparable to those already addressed in generative AI across various other domains. Yet it requires dedicated effort in generative AI research, where Perso-Arabic script is alarmingly underrepresented. Around the same time when I was finishing my master's, another type of generative AI network emerged, which quite drastically changed the public landscape of this technology. The emergence of diffusion models, coupled with transformer-based large language models, gave birth to text-to-image generation. These networks significantly lowered the technical barrier since they are pre-trained and only require simple text prompt from the user. But the transition to these networks was also a shift to corporate AI. Since training the models require gigantic data sets, sometimes billions of data points, and also enormous computational power. The famous example of these text-to-image generation networks is dominated by OpenAI. As you can see, in only 2 years, this network has seen significant improvements. And now the latest version, Domain 3, can generate unprecedented detailed imagery from extended text prompts. And it can even render text more accurately, something that has always been a challenge for this type of networks. So now, not only do we know what the depressed avocado says, but also we can generate text in a variety of styles and be more specific about the content. Although the performance of the system is not perfect, the generated samples are quite legible and there is a generation of accurate metaphors with consistent styles. A closer look, however, reveals that the improvements in details and text generation favor a certain script, which is not surprisingly the Latent. Having tried hundreds of text prompts in Farsi, Arabic, and in English, attempts to generate any text in Perso-Arabic script utterly fail. What is generated, instead, is beautifully decorated pieces of pseudo-script with hardly any recognizable metaphors. Trying to generate single words or even single letters similarly fails. Here you can see 3 different prompts. On the right, a prompt in Farsi was used to generate the word salam. In the middle, a prompt to generate the word mas'ul. And on the left, a prompt to generate the single letter vav. For those in the audience who are versed in Perso-Arabic script, it should be more than clear that the generated images are far from anything similar to the requested content. And for those who are not familiar, you can take my word, it's not a request. This phenomenon intriguingly mirrors the pseudo-Arabic found in European arts during the Middle Ages and Renaissance, and later in Orientalist paintings. In these contexts, the script is reduced to mere decorative motifs, divorced from its core elements and often without specific reference to any particular calligraphic style. This striking similarity suggests a persistent pattern which echoes through different eras and technologies. It signals a gap in generative AI's inclusion of non-Latin scripts, and it also raises questions about the trajectory of its development. While the arising biases in generative AI are often blamed on training data imbalances, these generative samples are already abundantly found on stock image platforms now, and will be part of the actual training data when the web is scraped again for another mega dataset. It is also hard to ignore the structural biases rooted in the consideration of what is focal and what is peripheral in the development and fine-tuning of these networks. So, as I'm continuing my research creation practice through small data approaches in generative AI, I am now more and more interested in the study of ingrained biases in the development of generative AI and its consequences for the visual domains marginal to the development of this technology, Perso-Arabic script included. While creative practices are being reimagined with generative AI, it is worth pondering whose imagination is driving its development and how inclusive this imagination is. It is also a call to action for playing a more active role in imagining the future, now that this technology is still emerging and cultural elements are at stake. Otherwise, we risk finding ourselves living inside someone else's imagination. Thank you.